All right, we're going to do the same thing in this example as we did in the previous two, except that now we have a function that has it has a factor of x plus 1, and we've already got it in factored form, which is nice too, right? And we have three factors of x minus 3, right? So we have one factor of that, x plus 1, and we have three factors. This occurs, this exponent is just shorthand for writing x minus 3 times x minus 3 times x minus 3, right? Those whole x minus 3's multiplied times each other 3 times. So essentially we have three factors of x minus 3. So this factor we say that the 0 that occurs at that point has a multiplicity of 3. So, okay, let's look at what the zeros are, right? The zeros occur when f of x is equal to 0, and that happens for x equals -1 and 3, all right? So we have x-intercepts at -1 comma 0 and 3 comma 0. Those are our x-intercepts. But this one has a multiplicity. Multiplicity of 3, right? Because we have three factors of x minus 3. So that we say that 0 has a multiplicity of 3. All right, now I don't have all of the steps written out as A, B, C, D, but we're going to go through the same steps that we just did for examples 1 and 2. It's just that they're not explicitly asked for. But we just asked to find the zeros and the long run behavior, but really we really need to look at the short run behavior of this function. So what I'm going to do is do what I just like in the other videos. I'm going to look at the factors x plus 1 and x minus 3 cubed, right? And the domain, I'm going to break the domain into, we have two crossings, so I'm going to make, or we have two zeros, so we're going to break the domain at the zeros and create three different intervals. So we're going to look at x less than -1. We're going to look at -1 less than x less than 3, and then x greater than 3. All right. And then we're going to look at the sign of f of x. So, all right. So when x is less than -1, right? So like maybe -5, right? Then this x plus 1 is negative. Now, when x is greater than -1, this factor is going to be positive. For the next factor, it's not going to be positive until x is greater than 3. So it's going to be negative when x is less than -1, and also when it's less than 3, between -1 and 3. So now we can find the sign of the overall function. Negative times negative gives us positive. Positive times negative gives us negative. Positive times positive gives us positive. So this will help us sketch the graph, because it tells us where the function is above or below the x-axis. So let's sketch what this looks like. I'm just going to draw some axes here. This is my x-axis. This is my y-axis. And I'm going to draw in where those zeros are. So we have one at -1, and let's go 1, 2, 3. We have one at 3 as well. And so we have zeros here and here. All right, so when x is less than -1, it's positive, right? So it's coming into -1 from the positive side of the x-axis, positive y values. And then it's negative all the way to 3. So it's going to dip down and it's going to come up to 3. But remember, we have a multiplicity of 3 on that -3. So it's going to look a little flat in that area. So what it's going to do is going to come in, it's going to flatten out a little. It's going to flatten out, and then it's going to cross the axis at 3, right? Because the function value goes from negative to positive. So That's sort of the general shape of what that function would look like. Again, we don't care about the actual y values. We're just looking at the general short-run behavior and where the value of the function is either positive or negative, meaning below or above the x-axis. All right, that's it for this example, and I'll meet you in the last video for the last example of this section.